Every time you use a chatbot, you perform a task that takes a few cents to complete. But in reality, these models cost millions of dollars to train. This video is going to explain that gap, the difference between training and inference. We'll also talk about how LLMs actually get built and the different careers in AI. In simple terms, training is actually learning, and inference is actually using. To create models like Claude, Gemini, and ChatGPT, companies like Anthropic, OpenAI, and Google give millions and millions of words to these models so that they can learn from it. And this takes a lot of computational power, which is what makes this process so expensive, and it costs millions of dollars. This is like the studying phase. It learns grammar, it learns different word patterns, and it learns how to reason, but you'll never actually see this. This process happens before a company releases a model, which is why you'll never see it. On the other hand, inference is just using the model. So what you do, you ask a question, it hits only one computational unit, a GPU, and this takes a few seconds and it only costs a few cents, and then you get your answer back. This process happens every single time you use a chatbot. There's an incredibly low chance that you're going to be training your own models from scratch. You're likely going to be more on the inference side, but when you're building AI apps, you won't just be using it like normal inference. You'll be building on top of it, and you'll learn more about that in later sections. So, how do these big companies train their models? Well, first they start with pre-training. This is the step that's the most expensive, where you just feed trillions of words into the model. And this takes a really long time too. But at this step, it doesn't know how to hold a conversation yet. All it can do is capture patterns in the data, so it knows how to complete sentences. So when does the model learn how to have a conversation with a human? Well, that's step 2. In this stage, you show the model how it should respond to a human. For example, when a user says this, you'll tell it to say a response that's similar to something like this. And then after that, it'll learn how it can actually respond to humans. This is a step where it goes from a sentence predictor to an actual chatbot. And it also doesn't teach the model any new information. All it's doing is that it's changing the model's behavior. The last step is reinforcement learning from human feedback. As the name suggests, what it does is that it takes in human feedback on the responses that it gives. So let's say the model gives 2 different outputs for the same question. The human will choose which one it likes better. And then based on this, the model will learn what preferences humans want. And this will lead to the model to cater towards human preferences. Human oversight also ensures that the model's responses are safe, and that's why a chatbot won't teach you how to build a bomb or how to rob a bank or something like that. So the pre-training gives knowledge, the fine-tuning changes its behavior, and the RLHF gives judgment. In section 5, we're going to go deeper into fine-tuning RLHF, so stay tuned. Okay, so let's say that a huge model goes through the training process we discussed earlier. Now, how do we actually work with it? Well, there's 5 levels, and you should probably go in this order. First is going to be inference, which is what we talked about before. That's just using it, like opening Claude, typing in a question, and getting an answer. It's either free or it's pretty cheap, and this is where everyone starts. Now, the next is prompt engineering. We'll go deeper into this in week 2, but it's when you use the same model, but you get better results when you write better instructions. In week 2, you'll learn how to actually write instructions, give specific examples, so that you can get the best results from AI without having to give expensive changes that we'll talk about next. Next is RAG, Retrieval Augmented Generation. You connect the models to your own data, and this could be maybe your company's documents, knowledge base, different PDFs, some domain knowledge that you want the model to know, but it might not know on its own. The model now can answer based on your information, not just what it learned from training. And this is how a lot of AI products work today, and we'll cover this deeper in week 3. Now let's say you don't want to add new information, but you don't like how the model is responding and you want to change its behavior. Well, you should use fine-tuning. A lot of behavior problems that a model comes with can be solved with prompt engineering, but some things require fine-tuning so that you can get better results. You only really use it after you've exhausted prompting and RAG. Last step is pre-training. There's no way you're ever going to use this unless you have a lot of money sitting around. It's best to just leave this step for the bigger companies. So it's pretty simple to make a decision. Start with prompting because it's free. If you need your own data, then use RAG. And if you want to change the behavior and prompting didn't work, you can fine-tune. This is the last thing I'm going to cover for week 1. if you're thinking about taking AI into your career, there are three main roles. The first is the data scientists. You ask why. You analyze a lot of data, you build dashboards, and you find patterns using AI. You're actually just explaining patterns in the past to help predict the future. Next is the AI engineer. This is the person who builds AI applications. Instead of exploring data, they build RAG pipelines, they build chatbots, they build agents, and they focus on deploying them to users. Both roles are equally important, but the second one is where all the hype is, because everyone wants to create cool RAG pipelines and agents and chatbots. Last is the ML engineer. This person asks how to scale things. You train the models, you optimize them, and you serve them at a massive scale. Without the ML engineer, the apps that the AI engineer builds could never be possible because the ML engineer ensures that the LLM stays running. You don't have to pick a role right now, but knowing these three roles exist can help figure out which ones you want to invest your skills into, because there are three different domains of AI, and this course will give you the foundation for all of them. That's all of week 1. Now you understand the AI family tree: machine learning, deep learning, generative AI, and LLMs. You also know what happens step by step when you type in a prompt: tokenization, embeddings, the transformer, and the prediction. You've heard of reasoning models, multimodal AI, and image generation. And you know how these models are trained. And you know the different ways you can work with these models and what the different AI careers look like. This is a serious foundation. Now in week 2, we'll start getting practical. We'll look at the actual AI landscape, what models exist, how they cost, how we can compare them, and how we can use them, with techniques like prompt engineering and APIs and vibe coding. And you also learn about the tools that you should start using today to keep up with the AI world. See you in week 2.